as we look at adding and subtracting radicals, it's important that we remember that we need to simplify all radicals first before we try to add or subtract. Once we get to that point, radicals with the same index and radicand can be combined. So a root x plus b root x, we can combine those together by adding the coefficients. We almost want to think of this as if I said 3x plus 2x, and you say 5x, that's because I'm adding the coefficients, leaving the x the same. So then when we get something like 2 root 3 plus 5 root 3, we're going to add the two coefficients and we make it 7 root 3. Now, add and subtract the coefficients only, keep that common radical the same. So now when we look at something like 3 root 27 minus 2 root 12, they don't have the same radical. I need to simplify them first to see if that happens. So we simplify separately to see if they match. So 27 is 9 and 3, which gives me a pair of 3's. So I'm going to go 3 came out, 3 left over. So square root of 27 became 3 root 3. Multiplied by the 3 on the outside, we now have 9 root 3. 2 root 12 is 4 and 3, which gives us a pair of 2's. Bring down this 2, it's 2 root 3, which makes it 4 root 3. 9 root 3 minus 4 root 3 gives us an answer of 5 root 3. Again, the important thing is that you simplify the radicals separately. To get common radical. So now when we look at our next one, we have kind of a complicated mess here. I have a squared, I got an a to the 4th inside, I have a cube root. I'm going to pick one, simplify it down, and see if I can get them to match. We'll start with the left one. 40 is 8 times 5. Gives me 4 and 2 and a set of 3 2's. So that brings a 2 out, it leaves a 5 inside, that's right here. A to the 7th, if I had 7 of them, in sets of 3, 2 sets come out, 1 left inside. So this is now 2a squared cube root of 5a. Simplify down, this is what I have. I need the other term to look like this. I'm going to make one little fix here. That should just be an a. Okay, so now 135 is 5 and 27, which is 9 and 3 and 3 and 3. So I got my set of 3's. So 2a on the outside, set of 3's come out, 5 left in. A to the 4th is going to take 1 set out and leave 1 in, because I have 4 a's. 1 comes out, 1 in. So now I have, it's addition, 6a squared cube root of 5a. They match, that's good, I can combine them. 2 plus 6 gives me 8. A squared cube root of 5a. So, we look at some more. 7 cube root 3 plus 2 cube root of 192. Now this is already simplified. I need to get this one to match. I already kind of know it. If it's going to work, it's going to have a 3. So let's just divide 192 by 3. That gives us 64, which is actually 16 times 4, 16 being 4 times 4, which gives us a set of 4's. So I got 7 cube root 3 plus 2 times 4 cube root 3 left over. 7 cube root 3 plus 8 cube root 3. My answer is now 15 cube root 3. Don't change that radical. Go to the next one. This looks pretty good. I'm going to leave it that one as it is and see if I can get the other ones to match. So 54 is 2 and 27. 27, it gives us 3 3's. So those come out. So I have 3 on the outside already. Set of 3's came out, cube root 2 left over. So this is 9 cube root 2. I'm just going to bring this one down. It's already simplified. And then I have to simplify our last term. 16 is 4 and 4, which gives me 4 2's. 3 of them I need. So this is going to become 7 times the quantity of 2 cube root 2, which becomes 14 cube root 2. Last thing I do is the coefficients. 9 minus 2 plus 14 gives me 21 cube root 2. Next we have 10 root 7, kind of already simplified, so I'll bring that one down. Or 10 square root 7, I should say. Square root of 28 is 4 and 7, which gives me a set of 2's. So that's going to be minus 2 root 7. Bring that down. Now I got 180. Well, 180 is 36 times 5. 36, the square root of it, gives me a pair of 6's. So that's 6 times 6 root 5, or 36 root 5. When I bring that down, now I can combine the terms together. 10 root 7 minus 2 root 7 gives me 8 root 7. Root 5 and root 7 don't match, so I just write them separately as 8 root 7, 36 root 5. Next we have fourth roots. 9 fourth root 3 is simplified all the way. Look at the other one and get it to match. 48, well I know I need a 3, so 48 divided by 3 is 16. 16 has 4 2's in it. So this is going to become 8 times the quantity 2 fourth root 3. This becomes 16 fourth root 3 added to the 9 fourth root 3 I already have. 25 fourth root 3 is my answer. Now for these last two we bring in variables. I'm going to simplify these down so they see if I can get the variables, the radicals, everything to match. This one's actually already finished. 4y can't be simplified anymore, so I need to get this one to look like that. If it does, I can simplify them. So 32 is 8 times 4, which is 4 times 2, and I get 5 2's there. I take one of those sets out, and then I'm going to have two of them left over, so I'm just going to put 4 because that's 2 times 2. X to the third, and it's a cube root, takes out one set cleanly, exactly. Y to the fourth takes out one set, leaves one left over. So I now write this as 10xy cube root of 4y minus 3xy cube root of 4y. 10 and negative 3 are my coefficients. Everything else matches, so that's 7xy cube root of 4y. Our last one here, the right side is simplified down. We need to see if we can get the left side to match. 98, I can divide that by 2 and it's 49. So that's 49 and 2. I get a pair of 7's from that. So 7 is going to come out. 2 is left inside, which is good. I can see that it's matching. X to the fourth gives me 2 sets on the outside, so it becomes x squared. Y squared becomes 1 set on the outside, and that matches. So we go minus 3x squared y root 2. 7 minus 3 gives me 4x squared y root 2.